In this video, I want to cover movement lag. So what movement lag is, well, kind of some additional procedurals when you move. So to kind of represent this, I went ahead and disabled movement sway and rotation lag, just so you can get an idea. So here, we only have movement lag. So as you can see, I move left and right, jump up and down. Likewise, if I were to crouch, we get that same effect. So I'm going to leave the others off for the time being, just to kind of focus on this little section here. So starting from here, use spring interpolation. So there are two types of interpolation that can be done. One obviously being spring interpolation, and that's what you just saw. So if I disable this, we will go back to the normal linear interpolation, which you can see is just a simple to and from. Now you can still get decent results with it. It is a little bit simpler, as you're really only modifying the interpolation speed, which I'll cover here now. So it's basically just a to and from. There's no additional oscillation hence the name spring. You don't get that springy effect. So if I were to drop the interpolation speed down to say 2, this affects how long it takes for it to get to the target. So you can see it takes quite a bit longer for the firearm to move left and right. So you can really go through and kind of tweak it how you want. But moving back to spring interpolation, Unreal has a nice little description here, so you can read it, and it tells you all the parameters of what they do. So the ones exposed are stiffness, critical dampening factor, mass, and target velocity amount. So those are the ones you're going to want to play with. Moving down, we have the left-right max and up-down max. Now the description is incorrect for these because it's been changed, so I need to actually update that little comment that pops up. But basically, it is the normalized range, so kind of inverted for what the description says. So with the value of 100, this is our result moving left and right. Now let's say I bump this down to 50. We should see almost double the amount. So you can see it moves over quite a bit. And likewise, you have the exact same thing with the up and down. So if I drop that down to 50 and jump, you can see it moves up quite a bit. If I revert it back to the default of 100, it is quite a bit less and more in control. And then same kind of thing, we do have our multiplier. So these are for specific axes. So for example, let's take the z-axis and we'll bump this up to something like 6. So we can just have it be dramatic. So left and right, sorry. X, Y, and D, Z doesn't always correspond to the same axis. So this one is a multiplier for the left and right. Put that back. We have our Y, which one of these does not actually have it in use. So Y is our up and down in this case. And then in this presence, X is not used due to the orientation of which we are going. So X would basically be forward and back, but there are no additional movement lag for forward and back. It's really not needed. So those are the settings. Those are what they do. There's more a written description on what these actually do in the GitHub wiki. But yeah, moving forward, I'm going to go ahead and re-enable these settings and leave everything back the way it was. So next up, we'll cover rotation lag.